The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, good morning, or good evening, depending on where you are in this world. My name is Charlene O'Hanlon. I'm the moderator for today's webinar, which is called How Cloud-Ready Alerting is Optimal for Today's Environments. We have a really outstanding webinar on tap for today, but before we get started, we do have a few housekeeping items I'd like to go over. First of all, today's webinar is being recorded, so if you miss any or all of today's webinar, just take heart in the fact that you'll be able to see it on demand roughly 24 hours after the event. You can go to devops.com to see the webinar on demand, and you'll also be receiving an email that has a link to the webinar on demand. And we will be asking questions of the panelists during today's webinar. So if you have a question at any time, please feel free to go ahead and just use your control panel and submit your question. Okay, let's go ahead and get started. How cloud-ready alerting is optimal for today's environments. Our panelists today are two really knowledgeable folks in the space. The first one is Aaron Pacheco, who's the product manager of platform services at Acquia, and Patrick Lin, who is the VP of products and partnerships at SignalFx. Welcome both. I appreciate your joining us today.
Thank you for having us.
So Patrick, why don't you go ahead and take it away?
All right, thank you so much. So what we're going to talk about today, first at a high level, we'll talk about some of the challenges that are in today's environments, and I'll tackle that. Then we'll hand it over to Chico to talk about how Acquia evaluated SignalFx and what their challenges were, pain points, and so on. We'll then take that as a launching point to do a bit of a deep dive into cloud-ready alerting, some new functionality that we've released recently, and we're very happy to talk about and very excited to talk about. And then we'll have Chico back on to talk about where they're planning to take their deployment next. And then we'll open up the floor for questions at that point. Okay, so let me go ahead and get started with the challenges in today's environment. And I think that this is a story that is going to be familiar to a lot of people. There's both a challenge and an opportunity around the fact that consumers today have much higher expectations of the experiences that the companies that serve them provide. Needs to be consistent, needs to be high quality, and oftentimes it needs to be done very quickly to avoid having competition come on the scene and potentially find a way to take away those customers from someone. And so what that's driven in large part is a need for those companies to be able to innovate more quickly. And in doing so, they've adopted the technologies, the processes, maybe even the organization that have been pioneered by web companies, SaaS companies, and so on, that allow them to innovate faster, right? You know, this is, in turn depends on cloud adoption in many ways, whether that's public or private, whether that's virtual machines or containers, whether that's infrastructure only or platform as a service, even function as a service, right? But that move to making use of those platforms and the development and operational processes that go with them is something that many companies are now doing. Now, what that translates to in terms of how the environment to be monitored has changed, there's a few things. One main thing is just that there are many more scale-out services because the capacity is so easy to spin up, because the types of web or data infrastructure that people are using are now often open source scale-out services. You're finding a lot more of that in the applications that are being developed in order to meet those heightened customer requirements. This also does depend on infrastructure that is qualitatively different than what it used to be in the past. Previously, you could rely on infrastructure as being a relatively stable thing that didn't change very frequently. But these days, whether you're using virtual machines in some auto-scale fashion or you're using containers to spin up and down on demand, the life expectancy of any individual component is much shorter, right? We're not talking about the years of a server lifecycle. We're talking about the weeks, the days, the hours, maybe even minutes if you come down and talk about functions of service. And so that higher churn does mean that it's a significantly more complicated environment to try to go ahead and monitor. The other complication that comes along with this is the fact that there are many, many more deployments of code. Code pushes are much more frequent these days, partly because of the desire to, again, innovate faster, but partly also be able to limit the scope of the changes that are pushed so that if you need to reverse the change, it's a relatively small backout of the code and a relatively small impact to the overall functionality of the application. So what this translates into in terms of the monitoring requirements, there are a few. The first is that the way you find problems and the way you alert yourself on them has to be based on more than a simplistic view of, hey, is a particular component up or down, right? At the scales that we're talking about with the kind of distributed application architectures and so on, you need to be able to look for patterns and trends across those and look at them in aggregates, right, for particular service rather than for a particular node which maybe just belongs to a cluster which is serving some kind of application service. And so a big part of the requirement there then is to be able to have analytics in the monitoring product that you use as a language for describing the more complex patterns that you're looking for. It also needs to be real-time and at scale. This becomes more and more true as the infrastructure that you're depending on becomes more and more short-lived and more ephemeral. If something changes and your monitoring is operating on a, say, per minute basis, then something might change, go down, whatever it is, and you won't see it until you're deep into a violation of your SLA. The last requirement that I think is really required here and taken advantage of by a number of people is the notion that monitoring is no longer just something that is done by an operations team or by particular infrastructure teams. And in fact, what you need is to have some common basis for what all of the people that are doing the monitoring are seeing, and the monitoring has now extended well into all of the development teams that are providing the application services on top of that infrastructure. Right? They need to be able to see what's going on for their particular service, because they can't just develop the code once every 6 months and toss it over the fence to some operations team. So with that, let me go ahead and turn it over now to Chico.
Everyone, thank you for joining. So next we're going to talk about Acquia's evaluation of different monitoring services that led us to the path to SignalFx. A quick overview of Acquia. We were founded in 2007. We are a largely open source hosting platform focused primarily on Drupal. We provide large enterprise, government, organizations, education, media with a hosting platform and specialized services for support and development of Drupal websites and related services. So we have over approximately 15,000 instances that we host various, probably hundreds or thousands of Drupal applications on. And we're responsible for monitoring them, debugging them, and providing assistance to our customers when they have application issues. So with this fleet that size and that number of applications running on them, we were presented with a unique use case when we began this evaluation. As I noted, some of the key things about our company, we're committed to open source. So when we were looking at potential vendors, the fact that they offered open source tools as opposed to, proprietary software for monitoring services was one of our key factors. We had to make sure that whatever we looked into would help us maintain our commitment to scalable cloud services and the performance of both the servers and the applications running on them. Because we do work with government organizations, banks, and media outlets, we had to make sure that security and compliance were considered when evaluating any vendor. And we had to make sure that whatever vendor we chose would have the flexibility that allowed us to potentially expose the data that we're seeing to our customers who are always thirsty for more knowledge and more insights into how their fleet is doing. A quick overview of how our structure works. So unlike other services which may have just a single instance per customer or may have a slew or fleet of instances that service all customers, Acquia is a bit unique in the sense that we offer different tiers of hardware for each of the needs of a website. So when a domain is pointed at Acquia, the first thing that the request will hit is our load balancing tier. So we have servers running Varnish and Nginx to serve the caching and do the general routing of traffic. We have web servers, which is where Drupal runs with PHP and our main caching tier. Then we have file system and database services, which is where our backups run, our MySQL, Gluster, our email. And then we also have ancillary services that customers can add on to their sites. So we host separate architectures for our search, our content filtration, and the like. And all of that is built on top of AWS EC2 instances. So it's not just about monitoring the instance itself for us. It's also about monitoring the related services that we built and then the software that runs on the hardware. So we had kind of a complex use case when we came into this about a year ago looking for a monitoring vendor. Some interesting data points about our fleet. Again, where we have over 15,000 instances, most of the vendors we spoke to, this was at the upper end of the size of fleets that they were used to working with. Some vendors had larger, but many vendors were not used to fleets this size for an individual customer. We were also, because of the size of our fleet and the number of applications we host, we were going to be sending millions of data points per minute, which again was a concern of ours, both in terms of can the vendor ingest that amount of data, but also can they render that amount of data in whatever UI. One third point that we were keeping in mind is that there are over 300 technical users at Acquia between our customer success teams, our operations teams, engineers, and the like. And then there are also some non-technical users like our account management team who would be interested in the data that any vendor would surface. So we needed one that was flexible enough to serve the needs of a few dozen different engineering teams, but also simple enough to use that even our least technical employees could get in and get around and get the data they needed, as long as we guided them along the path. So some of the key challenges we had with our existing monitoring services, every single team, so we started off with one main platform and then ancillary services and teams were built off of that. And each of those teams ended up using different tools to get different types of data. So we use Nagios primarily for our core platform with a check MK interface. And then we had a number of other teams that were using Mixpanel or Hosted Graphite and other systems like that to store and render the data. We also had hundreds of servers that were being used for monitoring itself, which was tricky to maintain and expensive as well when you have that number of servers just for maintenance. If we could go back, please.
That's right.
Sorry, I'm doing a quick overview. So it's tricky in that regard when you have a number of different teams and different people looking at data in different ways. We had an ongoing resource-intensive effort with regards to maintaining that number of servers for monitoring. The teams were interpreting the data in different ways, so even if they were accessing it from the same system, it was context deprived. So people would look at the data and they would each have their own opinion of what it meant. And then the final issue we had was that the number of alerts, both warnings and critical, coming off of a fleet of 15,000 instances was causing significant blindness to our operations team, wherein they were basically at a point where they could only respond to incidents once the server was actually having problems as opposed to before. So digging into those specifically, we wanted to have a single monitoring service if possible so that all of the teams are using the same one. That way everyone's speaking the same language, they're using the same UIs, they understand the services all at once. And it also saves on development time and maintenance if everyone's using the same thing. We didn't want to go to multiple sites to find data unless it was absolutely necessary. So it's one thing to have an application performance monitoring service and a log ingestion service and a server monitoring service. I mean, that's fairly reasonable. But when you have 4 different monitoring services, 2 different log services, and 3 APMs, it becomes a bit hectic to figure out which application and which servers are using which ones. Additionally, we only had access to about 35 metrics in our main monitoring service, and those were only polled once a minute. We wanted something that was a bit more granular and gave us far more insight into the actual services running on our fleet, as opposed to just shallow metrics like CPU, memory, and storage. And again, where the teams were interpreting the data differently, it was hard to figure out who was responsible for resolving inconsistencies in data, in availability of services, and who had the final say and what was the correct interpretation. So there were a lot of problems, and it led to a lot of confusion internally. Additionally, it cost us several $100,000 a year to maintain our current monitoring fleet, and we also have to dedicate engineers to maintaining it, which is not the most efficient use of our time when we want to really focus on value-add services and features and the like. And because the monitoring was developed several years ago, and by several I mean like 8 to 10, it wasn't modern, it wasn't flexible, and because it was built into the platform as a quote-unquote feature, in order to make any changes to the monitoring, it would have to go through the normal hosting release process, which could take weeks or months. And in that regard, we weren't flexible like we needed to be in the ability to fine-tune the monitoring and alerting thresholds. Again, with regards to inconsistent interpretation of data, the application specialists at our company, the operations specialists, and just the account specialists all had different ways of looking at the data, and some of them had access to different systems and others did not, which led to a lot of confusion, a lot of repetitive work, and we ended up needing to have subject matter experts just to break the tie between who was interpreting one thing one way and who was interpreting it another. And we really wanted to get to a new state where the subject matter expert was actually built into the dashboard and the monitoring. You can see, based on someone's previous analysis, that if you're at this red line or if you're seeing this alert, that a data analyst, a data scientist, or a specialized operations person has set that threshold specifically, and if you're seeing it, then you know that there's a problem. Finally, again, with 15,000 instances, there are any number of problems that can come up. Some of them are just warnings saying that this server or this cluster of servers is on an adverse trend, and at X amount of time there's going to be a problem. Then there are critical warnings saying the server is already impaired and somebody needs to look into it. And a lot of issues revolve around flapping, which is where the server is impaired but not, or software on it is not working properly, but it goes back and forth. So we were seeing thousands of warnings and hundreds of critical alerts coming out of our monitoring every single day, to the point where we actually had to start filtering out the ones that were non-actionable because we were spending so much time dealing with the ones that were. And it ends up causing a vicious cycle where you're only responding to things once they already break, whereas where you want to be in an ideal, optimal, efficient environment, you want to be responding to things before they break. That way there is no customer or service impact. And additionally, having all that noise, it makes it difficult in all those services. It makes it difficult for us to figure out where are we going to go to find the answer to this question, what caused it, and we would frequently have incidents where we couldn't really dig into the root cause analysis because there wasn't sufficient granular data to determine what happened in that small period of time. So in regards to why SignalFx ended up being the best fit for Acquia, we were able to create a centralized single source of truth for monitoring and statistic purposes across all of our teams. We were able to gain buy-in from all of our product and end user teams early, that SignalFx was an appropriate solution for them. It was something that would be easy to use and met their use cases. So we were able to build a coalition in that regard that said, okay, if you provide us with the service, we will be able to discontinue our other services and standardize. There would be the ability for our internal users to implement self-service functionality. So whereas before we would need to go through a hosting release and we'd ask other teams to make the changes to monitoring for us, what we can do now is our operations team or independent engineering teams can set their own thresholds and modify who they go out to when an alert comes in accordingly. They can build their own dashboards. All this functionality, all of the self-service makes our teams operate a great deal more efficiently. So we wanted to be able to to focus on that when evaluating vendors, and SignalFx gave us that in that regard. With regards to expert knowledge, capturing and sharing that data across the organization, like I said, we wanted to be able to create dashboards that encapsulated our understanding of what is considered performant and what is considered hazardous in terms of the availability of servers and their functionality. So we were able to do that in SignalFx by setting watermarks, or again, just by configuring specific detectors in a certain way, such that if you see that this thing is alerting, now you know why. You know that somebody has said that this is either an outlier in our system or the behavior is anomalous. By making sure that we had actionable alerts, we would be able to make sure that our operations team is only focused on the stuff that needs manual intervention. So instead of paging them at all hours of the day and night and asking them to look into the phantom issues that can't be resolved or there's not enough data to resolve them, SignalFx gave us the opportunity to provide detailed, granular data to our operations team such that they can investigate the issue more quickly and diagnose it more quickly, but also the alerts that they're getting out of the service and the alerts that they'll continue to get as we continue to evolve it will be more actionable and less questionable. And we also are looking into mechanisms for doing auto remediation, which would further reduce the burden on our ops team. And finally, where this is just kind of a plug-and-play service, it would save us from having to maintain large internal fleets ourselves and be masters of yet another domain and specialization. We could essentially rely on SignalFx's monitoring and expertise knowledge and their infrastructure to basically keep the service up and running, and all we got to do is make sure that we've got a single plugin installed and configured properly, which was a huge win for us.
Great, thank you, Chico. So let me now dive deeper into some of the functionality that I think we've recently released, and hope that will continue to provide dividends to Acquia. So taking one step back and talking about what SignalFx does in terms of cloud alerting, right? I guess there are a few things that are important to understand. It's not simply a matter of us being able to fire off alerts, right? Because there are many systems that can fire off alerts, and in fact, you don't want them to fire off too quickly because maybe the information is not very good. And so there are a lot of different things that we do to make the alerting better. The first is that, as Chico's mentioned, we're starting out with much better raw data that you can get in most of the other systems out there, especially legacy monitoring systems that rely on things like health checks. We have high-resolution metrics for common data infrastructure, web infrastructure, cloud type services, and also make it simple for people to get in similar high-resolution metrics for custom-developed applications or services. And so just from the get-go, you get much better data, and it comes in at a granularity that is actually useful for someone when they're trying to understand what's going on. As part of the data that is sent in, there's also a large amount of metadata that helps to characterize not just the source of that data, but also other important things about that environment. So maybe it tells you what team is using it, or maybe tells you what role or what service it's coming from, such that if you are seeing a spike in some infrastructure metric, you can then readily correlate it to the right cluster or the right region or the right team. And those are things that increase the pace with which you can solve problems and identify problems. We also, perhaps most importantly, provide a streaming analytics capability that allows you to create aggregate or composite metrics that are about showing you meaningful patterns and trends at a large scale, right? And so it's one thing to say, I've got good raw data coming in, right? So whatever, I've got my cache hit or cache misses coming in or whatnot. But it's another thing to say, well, maybe the raw data isn't exactly what I need. Maybe what I need is to understand the rate of change for that, or maybe what I need to understand is the ratio of that, right? And it's very easy within SignalFx to be able to create that kind of metric that relies on that raw data but then it's processed in real time and can be used either as the signal that you are watching when you are doing your monitoring and alerting, or it can be used also as the threshold, right, that you're using to determine if something is not working properly. And finally, getting back to the point about the appropriate speed, one of the key things that SignalFx is designed for from the very start is the idea that alerts should be something that you can trigger as soon as you see the real pattern, right? And so it can't be something where you have to wait a couple minutes for the data to have come in, to be stored on some back end, and then to be read on some polling interval to determine whether you've got a problem. You need to see it as the problem emerges as quickly as the data is available for that, and SignalFx makes sure that that can happen in a very low latency way and for scale to the thousands or tens of thousands of instances. And so on that basis, on that kind of platform, we've introduced a number of different things that I'm proud to talk about today. And we refer to it as cloud-ready alerting because we believe these are the types of capabilities that you actually need if you are running in a cloud fashion. Right? And so there are three key things that I'm going to be demoing here shortly. The first is the notion of the alert preview. And so when people are going ahead and trying to figure out what is the right thing for them to alert on, oftentimes it's a matter of trial and error, where someone will say, well, let me eyeball this and say maybe it should be higher than whatever, 1,000, right? And the only way they find out whether that is correct is to wait for the alert to fire, and hopefully not in the middle of the night when they would rather be doing something else. And at that time, maybe it's right, but maybe it's wrong, right? Maybe it turns out that the data that they were looking at was a local maximum and therefore needed to be set higher, right? Now, that is important, right, in terms of telling you whether the alert conditions that you've chosen, the thresholds you've chosen, would have triggered something to fire. But maybe more important than that is the ability to look for patterns that are more sophisticated than simple static thresholds, right? So I think a common thing that I see our users doing is they will start out with some static threshold because that's something that they've been trained to do. That's something they're accustomed to based on the state of monitoring prior to this current generation of monitoring products. And the reality is that, again, this is a relatively simplistic way of looking at the world. And if you have, let's say, weekly cyclicality to your business, right? Let's say you're busier on Monday mornings because of the kind of service you offer, or maybe you're busier on Friday nights because of the kind of service you offer, then it doesn't make sense to have a static baseline, right? And it also doesn't make sense to try and run some kind of job on some periodic basis that will say, oh, I think that Fridays are busier, and so I'm going to set a different static threshold on that Friday, because the nature of the services and applications that people are creating are such that it's very, very important to be able to have a constantly evaluated baseline to make sure you're keeping up with changes that are going on in your environment. And so these are the kinds of things that are important for people to see. And so we've created a number of alert conditions that are built into our product based on the underlying analytics functionality that we have that allow you to search for patterns like these. Okay, and I'll be demoing that very shortly. The last thing to mention here is that all of the functionality that we provide is available not just through the UI, but also via an API. And many of our, especially more sophisticated, more advanced users have taken to using that so that they can set up monitoring as code. The idea being that every time something new is set up, let's say in their infrastructure, then At the same time, they will set up the appropriate alerting for that and make sure that the conditions are correct so that the coverage of their environment is complete. Okay. All right, so with that, I'm going to go ahead and switch over to a demo of this functionality. And so I guess the place to start here is to mention the fact that with SignalFx, I think we're built very much out of the box for you to be able to see when something is changed or something is different, right? And one fairly obvious way to do that is to just give you a view of your environment as a whole and to give you a number of tools for being able to see what's going on there and to be able to drill down into the things that matter to you, right? So just as an example, let's say we're looking at an environment here and I know that I've named some of these services where, let's say I'm interested in the Cassandra groupings that I have, right? So let's just go ahead and use that and say, great, I'm going to filter this down to all the services that have Cassandra as part of them. And then let me actually go ahead and look at the different groupings that are there. And it looks like I've got 3 different clusters running Cassandra, right? Now, if I want to go ahead and alert on that, I can, of course, click on the bell icon for any of these. Now, what I'm going to do, instead of doing it from there, is actually take you to a dashboard where I've got some data that is associated with the Cassandra instances I was looking at. And the data in this particular case is the latency, this is around the load of reads that we've got in a Cassandra time series database, just as an example. Now, to create an alert off of this, I simply click on the bell icon and say I'm going to create a new detector from this chart, which then allows me to say, okay, great, I'm going to look at the data that is coming from that particular chart. And when I'm creating what we call a detector, which is effectively the logic that will trigger an alert, will generate an event that you can be notified off of. We'll show you in this view the ability to not only take a look at longer periods of time while still maintaining a detailed view of the data, but also the ability to go ahead and create a number of rules, one or more rules, on top of this data to figure out what's going on. Okay. So let's say we're looking at this, and yeah, this is a read scenario. So let's say we are worried about excessive reads, right? And let's go ahead and set the condition. Now, when I click on that, normally I think what you expect to see is the ability to go ahead and set a threshold, right? And certainly we have that ability. We'll talk about it here as a static threshold where we'll generate an alert when the metric that you're looking at crosses some static threshold. Now, you'll notice that there are a number of other alert conditions that are available here. We can do things like tell you if the metric hasn't reported for some period of time. We can tell you more predictive things. We'll tell you when a signal has a certain amount of time before it reaches a given value. So this kind of condition is super useful if you're looking at things like the amount of disk space, right? So, sticking with my Cassandra example, as with any storage-intensive service, if I start to run out of storage, I'm going to have some trouble, right? And so it's a great thing to be able to say, great, tell me when I have about 3 days worth of space left based on the trend in the growth, so that I have enough time to actually go ahead and get ahead of that problem by adding more capacity or switching it to some different infrastructure or whatnot. In addition, there are a number of things here that are along the lines of anomaly or outlier detection in some form or fashion. So one of the very useful things when you have scale-out services, things that are running in clusters, is the ability to figure out when something is not behaving like the others, right? And so that's what this allows you to do. Let's say you've got whatever, a cluster of 10 nodes providing the Cassandra service. We can tell you with a couple of clicks here which one of those is not looking like the others, because obviously in a cluster you're looking for it to be load balanced pretty well, right? So this will tell you how well the load balancing is working for that environment. We also have the ability to tell you when something has changed compared to its recent history. So for you to say something like, you know, the behavior of this thing over the last 5 minutes is radically different than the behavior of the same thing over the last, say, 24 hours, right? This is a very useful capability, again, along the lines of being able to keep pace with the changes that happen in an environment, right? So if you have the ability to have a very stable environment that has, you know, always the same kind of values, then you can say, oh yeah, you know, my baseline is 10, and so if it goes to 30, then I've got a problem. But if the baseline itself changes with some regularity, right, then you need to be able to see the change in a more relative way and have something that's constantly evaluating for that type of unexpected change in behavior. Next thing here is the example I talked about previously in introducing built-in alert conditions, the idea that you can find historical anomalies. So if a signal has some expected periodicity, whether it's daily or weekly or monthly or maybe even longer than that, and you want to say, is this behavior that I'm seeing now normal relative to this point in time, some amount of time in the past, compared to some amount of time in the past, then we can tell you that very clearly, so that when you are doing your baseline, it's actually a dynamically calculated, dynamically generated baseline that you're comparing to. And then finally, for those situations where you know your metrics and your systems and your applications best, and these don't do the trick for you, of course, have the ability to set custom thresholds, right? Just as you can use the analytics and filtering and so on to be able to specify the exact signal that you want to look at, which is potentially composed of multiple raw metrics. You can do the same thing with a threshold and simply compare them against one another to determine whether something should be triggered. Okay. All right, so now let's go ahead and take a look at how the alert preview works, because that's one of the more interesting things that you can see from here, right? Because you can then compare how well these detectors would find the condition that matters to you. So let's take the sort of common example of a static threshold, right? And so if I go ahead and look at the data above, and I'm looking at a 12-hour period, just because the default 15-minute view on this is probably not fine-grained enough, or likely to give me more of a local maximum. You can see that when I get to, I don't know, about 1600, 1700, something like that, it looks like it's higher than everything else, right? And that might be the thing that I would want to trigger some notification on. And so, the normal thing for someone to do would be to say, oh, great, let me go ahead and stick the number 1600 in there. And when I go and look up here, what it's doing is it's going to run the preview, and it's going to take the data that I have, run it against the static threshold that I've got there, and then tell me when it would have crossed that threshold, right? And so it's telling me that it would have actually generated 772 alerts in the past 12 hours. Now, obviously, this is going to be contributing pretty significantly to alert fatigue, which is not great, right? But it's better to find out now than to set it and then wait for it to fire, right? Because then you're in panic mode trying to figure out whether you need to actually respond to it or not, or the person who's responding to it may not be the person who set it up. Right? And so the context is something that needs to be captured correctly. And so as it turns out, I happen to know that this particular metric has some periodicity to it, right? And so I'm going to go ahead and switch to a different type of detector, different type of condition. And so I'm going to pick the historical anomaly one, which will look for cyclical or seasonal data. And compare it against, in this case, I've specified a 1-week cycle length, right? And so now what this is doing is going ahead and comparing it against the same time over not just last week, but also it's going to take a look at the past, I believe, 4 weeks by default for that point in time, throw out the things that look like complete outliers, and then do calculations on that to tell you that, hey, this is something that compared to the historical baseline is in fact anomalous, right? Something that you might want to pay attention to. And so you can see that this detector on the face of it looks to be probably a lot more appropriate. Generated a much more palatable number of alerts, even though I likely would have wanted to get to an even lower number. And of course, this is the kind of thing that you can tune, especially if you have, let's say, an incident that happened and you know that that's the data that's going to tell you, hey, I want something to have fired at this point in time, but not for these other points in time. This sort of preview condition would allow you to try different conditions and see whether it would have actually found the problem that you have not, right? And you, of course, if you want to go further, you also have the ability to go and set any number of parameters that are even more fine-grained controls over the algorithms that are in use here. Okay. But the good news is that SignalFx and the data science team we have has gone and created these so that they're available out of the box for any user of SignalFx. Now, the last thing I'm going to show here really quickly is the fact that let me go ahead and I need to actually say OK. Sorry, and then let me go ahead and save. I'll make myself the recipient of this. Of course, we have the ability to send the alerts coming from here to any number of different sources. So I'll go ahead and save this with myself, getting notification. You know, I have some confidence I'm not going to get woken up at a bad time. So go ahead and save that. And now, if I want, I can also go ahead and take a look at the API calls that are behind the thing that I've got here, right? And so if I simply go to this menu, choose Show Signal Flow, what will then show me is effectively the API calls that I would have had to make to generate a similar detector, or actually exactly the same detector, right? And so this goes to the point of the fact that we have a fully built out alert functions library. And so as I was showing you there, the models that are in the built-in alert conditions are available there via the API. And this provides you with the opportunity to further customize what's being done so that you actually have a good view into how your application, your environment are performing, and make sure that you're capturing the right thing, right? And I think that again, for folks who get to this stage of understanding their environment well, right? They will then oftentimes turn over this capability to operations analysts, data scientists, performance engineers, people who have the job of understanding and helping to model situations that you need to be looking out for, right? And this is something that is extremely powerful for that use. Okay. So with that, I'm going to turn it back over to Chico so that he can talk about where they're planning to take things next.
Awesome, thank you. So some of the key benefits we've had with SignalFx to date and where we're headed with these things. So where before we would only be able to look at individual instances one at a time or specific metrics one at a time, with SignalFx installed and running, we were able to get instantaneous visibility across our entire fleet into over 220 different metrics. So again, coming from a world where we were looking at 35 metrics once a minute, we can only see one server at a time, one metric at a time. We were now able to see all of our instances up to 220 different metrics at 15-second granularity instead of 1-minute granularity. So it was eye-opening for us. And even within the first few days, we found about half a dozen different issues that we needed to look into and start investigating because we didn't know that there were errant problems in different portions of our site. We were able to implement a single shared self-service monitoring service for the entire organization. So when new product teams needed monitoring for their services, once they were ready to go into alpha or beta states, they would just work with SignalFx, go in, get a token, start building dashboards, and they'd be off and running. Whereas before they would need to do an evaluation period, find a vendor, get budget and funding and all that stuff. So we've been able to streamline operations there, and now everyone's using, for the most part, one service and just different dashboards in that service. Whereas before, only a few dozen people at Acquia had access to our monitoring services, we now have 304 people accessing monitoring on any given day, which is obviously a massive leap. Now, instead of our teams blocking each other whenever they need something, people can unblock themselves, go in, access the data, get the interpretations of the data already built into the UI, and do everything they need. So we've been able to work more efficiently. Because it's easier to make configuration changes directly in the UI, we've been able to fine-tune our monitoring minute by minute as opposed to month to month or quarter to quarter during some really bad times, which has been huge for us. And especially with the new functionality where when we're going to define alerting thresholds, we can see how frequently it would have alerted. We know instantly whether or not the threshold we're hoping to define is going to be unrealistic or not, which has been huge. And also, I mean, the service from SignalFx is vastly more powerful than anything we had before. Whereas before we were struggling to render a UI and maintain a fleet of instances to monitor 15,000 servers, SignalFx doesn't break a sweat when we send all of our data at it. And even during spikes, the application's performant and the backend renders the data almost instantaneously when we send it, which is a huge, huge change of pace for us. And because the data is more accurate and more granular, we're able to fine-tune the alerts more carefully and make sure that if we're alerting, it's not because of some transient issue. It's something that's happened across multiple detection grids and periods. And whereas before we would say, if this has happened 3 times, alert, or whatever, we could say, if this has happened 3 times in 10 minutes, alert. Or if this has happened over X period of time, or if it's an outlier. All of these are things that we never would have been able to do with our old service without some significant development effort. So looking ahead, we've got 4 things that we're trying to do to improve our products and services even further. First is incident auto remediation. We're finding, and what we kind of already knew, is that a lot of the incidents we deal with don't require a human to be involved. So whereas previously we would detect an issue, page a human, and a human would do a bunch of work, and then page another human on our customer-facing team, who would then page another human, we would really like to just have the monitoring contact a service, correlate the events in case the servers are related. So where an application might have 15 different servers, and rather than getting 15 different alerts, we want to get one alert that one customer is impacted. So the ability to go from that and then say, okay, based on the nature of this issue and the severity, we're going to kick off an automated upsize. We're going to kick off an automated restart of PHP. We're going to automatically notify the customer because this doesn't require a support or operations person. So that'll allow us to scale a great deal more efficiently as a company as we add more customers than the current model, which is just adding support and ops people at a certain rate depending on the number of servers and customers we have. With the automated diagnostic tools, when an incident does get to a human being, we can automatically trigger certain analytics to go into the ticket. So that way we can say, okay, we know that there is high CPU utilization. We've run these 15 checks against it, and we've ruled out these common root causes. That allows our engineers to focus more closely on what has changed and what is potentially the issue. With predictive alerting mechanisms, again, something we never would have dreamt of before, we can start seeing that customers are on an adverse trend before it reaches a critical threshold. So we've been using this most recently on storage full. Some customers will hover at 90-95% storage full forever, but other customers will go from 80 to 100% full in a matter of hours for various reasons. So the ability to alert on how quickly an issue is becoming, how quickly resource utilization or certain behaviors are trending towards disaster is huge for us, because now instead of alerting on something that won't be an issue for weeks or months, we can alert on things that are really time sensitive and require action quickly. And then finally, we really want to expose this data to our customers. Our customers are thirsty for more information about how they're utilizing resources on our instances. So by taking this data and using the SignalFx API to expose it to customers on our website, they can see, okay, I'm using a lot of CPU after my code deploys, or when I clear cache, my CPU and memory utilization spike. Or, hey, there was a traffic spike, maybe that's why my application is slow. So all of this contextual data is not just insanely valuable for Acquia, it's really incredibly valuable for our customers, and we're excited to provide this functionality to them.
Great. Thank you, Chico. So let me go ahead and just leave one last slide up here while we get started on some Q&A. Chico has written a blog post which provides some additional detail and context around some of the things he's been talking about today. I'd encourage everyone listening to go ahead and read that. It's extremely, extremely insightful. There's also a lot of additional information available on the Cloud Ready alerting that I demoed earlier today. I think there's probably no substitute for actually simply just trying things out. For products like this, the most important thing is that you're able to see what it actually does for you with your data. And I think that, a free trial that we offer is a great way to do that. So invite everyone to go ahead and do that. And so with that, let's go ahead and open the floor to some questions.
Okay, great. Thanks very much. We have gotten a couple questions in, but there is still time. If you have questions for Patrick or for Chico, please feel free to use the control panel there and submit your questions. If we don't get to your questions during the webinar, I'm sure these guys would be more than happy to follow up with you guys post-event. So don't feel like it's too late to get your question in. Okay, Patrick, the first one is for you. This question is about scalability. The person is wondering, how is SignalFx more scalable than other vendors?
Yeah, that's a great question. I think Chico hit on one of the key things that everyone looks at during his section here, where he talked about the ability to ingest large quantities of data, right? And certainly that is what I would consider table stakes, right? Can you take in the quantity of data that someone wants to send at the rate that they want to send it, so that you actually can put your data somewhere, right? But actually what I think matters a lot more is what you do with that data beyond storing it somewhere, right? Because, storage is cheap these days. You can probably find some place to put it. But what's more important is that you can do something useful with that data, right? You want to be able to do the kind of analytics that we do at scale. You want to be able to do alerts based on analytics that are able to scale to those environments and at that rate at which the data is coming in, right? And you need to be able to do all that in a super, super timely manner. So when you're talking about the dynamic or high churn, ephemeral, elastic environments, right? Then the scalability around reading the data, being able to do something with it, generating the right visualization or the right alert for you. That's where I think our scalability really shines. Okay. All right. Great. Thanks. Our next question is for Chico, actually. This person is asking, how were you able to advocate for a new monitoring service at Acquia? Sounds like maybe they're gunning for some new technology.
That is a phenomenal question. It was a little bit like pushing a boulder up a large hill. When I landed in my current role, it was nowhere on anyone high level's radar that we needed a new monitoring service, because the teams that relied upon it were just kind of quietly, or sometimes not so quietly, living with the status quo. And when budgets are tight, it's hard for anyone to even raise the topic of, hey, can we invest in a new monitoring infrastructure that supports this large size of instances. So the first thing I had to do was get data. So at the end of the day, it all boils down to money and impact. So I took qualitative data from our end users internally and determined that this is a major pain point for them. It impacts the quality of their life and the quality of their job. And I was able to take the next step and go into quantitative data analysis. So how much time were we spending investigating issues using the old outdated monitoring service? And that was actually one of the huge points right there, is when I discovered that support, our application support team and customer facing team, was spending about 33% of their time dealing with critical incidents, and our operations team was spending 65% of their time dealing with incidents. And in a perfect world, you would be at 10 or 20% unplanned work on any given team. So this was really suboptimal. And when you throw a dollar value at that number of hours, we were looking at hundreds of thousands of dollars, even in the millions, low millions range, for how much money and time were being wasted trying to identify problems when we could be auto-remediating them or diagnosing them more quickly. From there, I had to build a coalition and establish a sense of urgency. I think this is part of Cotter's 8 steps. And what we did next is we went around to the different teams that were impacted by the monitoring services, and we got them and their high-level leadership to agree that this is a problem we need to resolve, and yes, this is a pain point, and this is the impact it's going to have on the organization and our strategy and our competitiveness over time. So we would have to add X number of new heads. We would deal with a certain degree of burnout. One thing that actually was in my favor when this happened is we actually lost 5 employees all within about 6 weeks of each other that were just tired of the amount of alerts fatigue that we were having. So it really became a pressing and really visible issue for our executive leadership team when we were saying, one, the team that manages our fleet is not able to keep up with the alerts. 2, this is costing us hundreds of thousands of dollars. And 3, we're not able to satisfy the needs of our largest customers who want to see more visibility. And we had tried this. The thing working against me was that we had tried this 4 times before to build our own, and that didn't work. So I had to essentially form a business case that said, this is the impact to Acquia if we either try to build this ourselves, go with some other open source service, or go with a SaaS vendor. We looked at a number of SaaS vendors. We determined that was the most economical route to go. We just needed to find one that met our business needs. Then again, we formed a coalition of engineers to determine that this was the most reasonable technical approach to solving our problems. We had to form an alliance with a bunch of executives across Acquia to say that they would agree to help fund this initiative because of the impact it would have and the fact that it would benefit our customers in the long run. And it really went all the way up to the top of our organization and the board saying, are we willing to, at a critical time, invest this money into a service like SignalFx, or are we going to try and make do without it? At the end of the day, they saw reason and said that we can't afford the risk of not having SignalFx. And really that was the clincher for us. But it took about a year internally to get to that point.
Okay. All right. Great. All right. Thanks for that answer. We have a question here from Josh, which is a little more technically oriented. So I'm just going to throw it out to both of you, and then whoever wants to answer can. The question is, we use SignalFx for our monitoring, and an issue we have had is tuning the alerting around service bounces. 95% of the time, a bounce for a single instance service will finish within end time, and we alert if service is down for more than end time. But 5% of the time, a legitimate bounce will take longer. Any advice for a strategy that would allow us to prevent alerting on the 5% bounce cases while not slowing our response capabilities for the other 95%? That was a mouthful.
That is a mouthful.
Yeah.
So I think the quickest answer there is going to be for since it sounds like they're a existing customer of SignalFx, simply to send in a note to our support line. Support@signalfx.com is fantastic. I think Chico will probably attest to that as well.
Love them. Love them.
Helping out our customers, and so we'll have an answer through that channel.
Okay, great. So Josh, take a look out for that then. Okay, next question is from Isaac, who asks, does Acquia use additional tools on top of SignalFx to manage distribution and escalation of alerts across different products and services, support rotas, etc.?
Yes, we're actually in the process of building that right now because of the complexity, and this is something we've talked about extensively with Signal, and we determined that, especially for our unique use case where we have applications and clusters and the like, we had to build our own thing, and essentially the logic we have is that the monitoring alerts to an intermediary, what we call an incident response service, and it looks at things like, are these servers related to each other, one, and 2, is this incident related to other similar incidents that have been reported? So the context of the issue, not just the servers impacted by it. And then the third thing it does is it says, are there any events in flight that would render this alert meaningless? Meaning, is there maintenance of some sort underway that we would expect there to be an alert and we don't want to action on it? So we do have an intermediary service that we've been working on to process the alerts and further fine-tune them, so that way the stuff getting through to our end users is actionable. And then again, we also want to build in some auto remediations there, which we're still working on.
Okay, great. Well, unfortunately, we have run up against the top of the hour, so I do want to thank Patrick and Chico both for presenting such a really interesting and awesome presentation and demo today. I'm sure the audience got a ton out of it. I do want to remind the audience to check out devops.com for future webinars, as well as an on-demand version of today's webinar. And with that, I'd like to say thanks again, and thank you for joining us today. My name is Charlene O'Hanlon, the moderator for today's event, and I'm signing off. Have a great day.
Thanks, everyone.